Hey, this is Mr. Beckstrom, and today I wanted to talk about some of the concepts from 1.2. This is on types of data, and I specifically wanted to talk about the differences between discrete and continuous data. 'Cause a lot of times students will have a little bit of trouble with this because the definitions are a little bit confusing. So let's jump right into it here. Discrete data is quantitative data. So quantitative, let's kind of define that. That is something that can either be measured or counted. That's in contrast to qualitative data. Qualitative data is usually something that can't be counted or measured, like eye colors or something like that. So quantitative is something that can be measured or counted. That is finite or countable. Finite means that there's a certain fixed number. For example, the number of people in your household is finite because there's a certain number of them. It can't go on infinitely. So finite is the opposite of infinite, right? There's a certain number. And countable means that we can count it. We can start at some number and keep counting forward. So if either of those are true, if it's finite or countable, we consider that discrete data. And continuous data is kind of the opposite. It's still quantitative data. That means it's still data that's either measurable or countable, but it's infinite. That means there's an infinite number of possible values, and it's not countable. What does that mean that it's not countable? And I've discussed this with a lot of classes, and kind of the easiest way that I've found to visualize this and to talk about this is using this rule of thumb here. And the rule of thumb I like to use is that if you can find two data values with no other data in between, then we consider the data discrete. And what does that mean? It means that with continuous data where it's not countable, that means no matter what two data values that you find, you can always find data in between those two data values. And you can keep doing that infinitely. So let me give you an example of that. Let's say we were talking about somebody's height. Height is continuous data. The reason is, let's say I said, okay, I took the two measurements, 4 foot and 5 foot. Can you find anything between that? You said, yeah. Well, how about 4 foot 5 inches? Okay, how about between 4 foot and 4 foot 5 inches? Can you find anything between it? Sure. How about 4 foot 1 inch? All right, 4 foot and 4 foot 1 inch. Can you find anything between that? Sure. 4 foot and a half an inch. All right, how about between 4 feet and 4 feet and a half an inch? Is there anything between there? You can actually keep doing that. You can say, okay, 4 feet and a quarter inch, right? And well, what about between 4 feet and 4 feet and a quarter inch? Is there anything between there? Yeah, 4 feet and an eighth of an inch. You can keep kind of adding the two values and dividing by 2 to find the midpoint of those two values and finding a measurement that's between there. So we have an infinite number of values between really any two data values, which makes the set of data continuous. So that's what I like to do with a lot of these examples that we look at. We say, can we find two pieces of data that there's nothing in between? And if we can find two pieces of data where there's nothing in between, then we can say, okay, that's going to be discrete data. But if we can't, if we notice that no matter what two pieces of data we find, we can always find something in between, then we consider that continuous data. So let's look at these 4 examples here and decide whether or not these are discrete or continuous. At this point, I'd like you to pause the video. I'd like you to think about these, talk about think about the rule of thumb. Put a little D or C, maybe on a piece of paper there for each number. See what you think. And then we'll go back and talk about it. All right, so let's go through this. The first one says the exact circumference of planets. So there's lots and lots of planets out there. I didn't specify in our solar system, so that, you know, there's probably billions of planets that we even know about. So the exact circumference, that's the distance around the planet. Well, that's a measurement. And once again, there's no two data values that we can find where we can't find one in between, right? Let's say we said, well, what about 1,000 miles and 1,001 miles? Well, you can just add them up, divide by 2 to find a value right in the middle of there. We can keep doing that. So just anything that's a distance like that has no breaking points, and we'll talk about how kind of like a breaking point works with like shoe sizes a little bit later. But that's going to be continuous data. It's going to be continuous. So measurements like that, exact measurements, are usually going to be considered continuous data because we're going to have an infinite number of values between two set data values. All right, the next one is the number of planets within 1,000 light years. Well, think about that one. And that one is going to be considered discrete. Why? Because that's going to be countable. That's something that we can count. Let's say we found 5,036 planets within 1,000 light years, right? That's an exact finite amount. And if it's finite, then it's considered discrete. Yeah. So how about the average surface temperature of planets? Well, think about the temperature, right? Is there anything between 78 degrees and 79 degrees? Yeah, there's 78.5 degrees, right? Is there anything between 78 degrees and 78.5 degrees? Yeah, there's 78.25 degrees, right? And we can keep doing that. So temperature, like distance, is one of those types of measurements where we can infinitely go between any two data values. So that makes it continuous because it's infinite and not countable. And then the last one is the number of craters on a planet. And once again, we can count that, and it's going to be finite. So that would be considered discrete. So take a look at it, do some exercises from the homework. Make sure that you understand this, and if you have any questions, please let me know, and look forward to seeing you at the next virtual class. Thanks, and have a great day.